Hi, I'm going to go over the questions from Felicia. That's the section 4, 28 minutes, 19 questions. So let's go ahead and begin with number 1. In this one, we have an exponential function. And we have to understand that when we have an exponential function, the a, which is the coefficient in front of the exponent term, that represents the initial value, or the y-intercept. And then if the b is greater than 1, the amount that is above 1 represents the percentage increase that's occurring. Of course, if it's below 1, it tells us by how much below 1 it is, what the percentage decrease is. In this case here, it tells us that we're starting at 375 and we're going up by 2% every time the m, which is the number of months, goes up by 1. Right? And that's what an exponent does. It tells us how many times we multiply. So if we keep multiplying by 1.02, we keep getting 2% increases. So obviously, then A is the one that is the meaning of the initial value. If we go ahead and look at number 2 next, we now have an exponential, we have a linear function as compared to number 1 with an exponential function. In number 2, this linear function, we can think of it as y equals mx plus b, where the c is replacing the y and the s is replacing the x. A better way to think of the equation in order to kind of see that m a little bit more clearly is to bring it out in front as a fraction, 1 over 18. So that's the slope. And then the 3 represents the y-intercept, or same as in the exponential function above, the y-intercept represents the starting value. So if the slope is the rate of change, right, and it's 1 over 18, what's the value on top? It's the change in y, or in other words, the change in c, in this case here. And on the bottom, it's the change in x, or in this case here, the change in s. So that lets us know that one class is going to contain 18 students. Every time we increase the number of classes by 1, the number of students, s on the bottom, is going to go up by 18. It doesn't really make much sense, but it's the best we can do with that particular slope. Okay, number 3 is a case where we have a ratio question. Um, on the ratio question, we know that the values in the ratio don't necessarily represent the actual number, the values, all right? So it doesn't mean that we actually have 5 juniors or 7 seniors. It's possible, but most likely it's not. So one good way to think of that is to just think of it as 5x to 7x, right? We know the true number of juniors and seniors is some multiple of 5 and 7, respectively. So if you can think of a ratio like that as 5x to 7x instead of just like 5 and 7, then that helps us make an equation, an algebra equation out of it really easily. So 5x plus 7x is going to equal to the 84 total students. We'll then find out what the multiplier is, and then we're able to go back and plug in to find out the true number of juniors and seniors. And they're asking for how many more, so we have to just take the difference between those two values. So 49 minus 35 is 14. On to number 4. So this is a probability question from a table, and this is the most common type of probability question that you'll see on the SAT. Oftentimes, this type of probability question is going to be on section 4. Section 4, they have a lot of tables and charts and graphs and things like that. So probability as defined is the desired, what we want to get out of the total amount. Okay. In this particular case here, we are choosing from any student at random. So that means in this case here, we're going to look at all of the possible students. And from here, since, we're basically being told that every student is wearing like a different kind of combination of top and bottom here, we can just add up all the numbers in the bottom. So if we add up all of those kind of subtotal amounts, we are going to get 148. Now, out of all those students, right, we want people who are choosing a red top, and that means that it's 12 out of those, and we can simplify to the final answer. Okay, so number 5 to 7 all refer to the information in this little scatter plot. So remember, in a scatter plot, the points represent the actual data, whereas a line of best fit would represent what the estimate or prediction is. In number 5, we're looking for the May. All right. So remember, on the bottom, it tells us that it's a number of months since January. So 0 represents January, then February, March, April, May. So it doesn't make much sense in terms of our brain thinking of like what May is numerically, but since it's a number of months since January 1st, the 4 months actually represents the May here. And if we look at those 3 points that are directly above May, we get these values basically. And of course, we can use our calculator to add them all up and divide by 3, since there's 3 prices, and we get 533. In number 6, we want the range of prices for all of the 4-packs collected prior to May. So if we look for the lowest price in the table above, in the scatter plot above, we're going to get the point that is 4.25 in February. All right, so if you look at the lowest value, and remember the dollars is on the vertical axis, the lowest point is going to represent the smallest number, the minimum. And then, of course, the highest is going to represent the highest price as well. So as you can see here, I've extracted that information. It's 425 in February. The highest is 550 in April. And if we do the difference of that, that means that the range, the difference between the minimum and maximum is 125. In number 7, we're trying to find the equation of the line of best fit. So this can get a little bit tricky when the points are kind of scattered like they are here. But I think the most important thing here to realize is that the endpoints are usually the best in determining the most accurate kind of value. So as you can see here, I went to the left and I saw that there's 2 points there. So I kind of averaged out those 2 points on the leftmost, and they use that as one endpoint. That's 1, 4, 50. And on the right-hand side, I looked at the 3 points there. I kind of averaged it out, or I just kind of eyeballed it, and I said, well, that estimate is approximately 6, 6.25 among those 3 points vertically. And that means that we can do a slope calculation. So that's going to be approximately 0.35, and that matches to either C or D. But that 0.33 looks pretty good. And then what's the y-intercept? If you plug in, or again, you could eyeball it, then it looks like the y-intercept should be approximately 4.2 rather than 4.5, right? It's dropping down a little bit further to the left. So that's why I went with C, and that's the correct answer. So use your endpoints when you're looking for the slope. Okay, number 8. In this one, we are working with a pretty standard system of linear equations. So we have the option of either doing substitution or elimination. I decided to use elimination. I saw that there's a minus sign for the y in the first equation and a plus sign for the y term in the second equation. So I said that, hey, let me multiply the first equation by 2 and then get the y's to cancel out. And of course, if we do that, we can solve for x. We get an x value of 0. And guess what? There's only one answer choice where the x value is 0. So we don't even need to get around to solving for the y. If you wanted to, just plug in the x equals 0 into one of the 2 equations above and find the y, and it would be equal to negative 19. All right, but stop right at x equals 0 because of the way that the answer choices are displayed right there. Okay, so on to number 9. This one's pretty straightforward, I think. You just have to remember how to distribute that negative sign to both terms inside the parentheses. So basically minus times minus is plus. So this turns into plus xy cubed and also plus 2xy. So if you combine like terms, the end result is what you see here in B. In number 10, we're looking for keywords in that, and we see the keyword perpendicular. So that means we can take the slope as it's displayed into this y equals mx plus b form line and do the negative reciprocal or opposite reciprocal. That might be what your teacher taught you in school, either opposite or negative reciprocal. So change the sign, negative becomes positive, and then 1 over 2 becomes 2 over 1 or 2. And this is a place where you can use the point slope form of line pretty conveniently. So that's what I did over here. You could also take x equals 2 and y equals 4 and plug it into y equals mx plus b. You know the perpendicular slope is 2, plug in x equals 2, y equals 4, solve for the b, and then once you solve for the b, you can then check your points and by plugging them in and see if anything works out to be true. In this case here, I thought it would just be faster, and it probably is slightly faster to get the equation to line immediately without having to solve for the b separately. And 816, when you plug it in, that does work. That is true. So that means that's the point on the line. In number 11, there's something here that should have been mentioned that isn't. They should have mentioned that it's true for all values of x. In other words, there's an infinite number of solutions. It doesn't matter which value of x is used in the equation above. If that's true, then in this type of equation where there's infinite solutions, or it's true for all values of x, then that means that the left-hand side variable terms have to cancel out the right-hand side variable terms as well. Okay, so if I look at both sides like they're linear, okay, in other words, mx plus b form, that means on the left-hand side, the two x terms that we get by distributing and working on it are going to have to come together to become 12, right? So m plus r is going to have to equal 12. So we can just go and look at the values of r that are listed. There's only 4 possible values of r that are listed there. Take them and work out what the m would be and just see if that tells us something that is workable, all right? So you could see here. Um, A is the only one that will not work because B has to be an integer. The other answer choices all give us integer values of B. So just look backwards, plug in those R values in order to figure out what the M and therefore the B is going to be. Okay, on to number 12. This is a situation where it's basically a common denominator problem, right? So we have fractions in an equation. We could find the common denominator. I chose to clear the fractions by taking what would be the common denominator and actually multiplying. And when you multiply, instead of doing a common denominator, it just kind of clears out the fractions in one step. And then it becomes an easy question to solve for what the x value is. Okay, so just check out those steps and make sure you can see or understand how that multiplying by x plus 5, x plus 2 basically clears out all the fractions. Let's look at number 13. So in number 13, one of the key ideas here is that f of x equals y. So the value inside the parenthesis, that always represents the x value, or in other words, the input. And then the value that it's equal to, the value of the function, is equal to the y value, right? So again, f of x equals y. Here they're using h, but it's still a function, as in the function f, here the function h. So if we find h of 3 first ourselves, right, by plugging in x equals 3 through substitution, then we will get a b value of 2, right? So we plugged in x equals 3 ourselves and worked on the right-hand side. We set it equal to 0 because they told us that the numerical value is 0, but we've substituted it in and got 6 minus 3b, and then we got the b is equal to 2. So now we know what b is, all right? So we know that h of x in a easier to understand form would just be equal to 2x minus 6. So now we can find the value of h of 6. Again, the value inside the parenthesis represents the input or the x value. In this case here, x equals 6. And if we do the math on the right-hand side, we get a final answer of 6. In number 14, this is an in terms of question. And on an in terms of question, what happens is we're just solving for m, right? But we're not going to get anything numerical, as you can see from the 4 answer choices, right? It's all m equals, m equals, m equals, m equals. But on the right-hand side, what are we doing? Well, in algebra, we are used to isolating the variable. Like if I gave you an equation and I said solve for x, you know that you want to kind of isolate the x on one side, and then whatever x is equal to on the right-hand side is the answer, the solution. So in this case here, even though there's all these letters and complicated things, just think of that giant thing in front of the parenthesis m minus f as just a fraction. And if we want to solve for m, that means that we have to get the fraction over to the other side. How do we do that? We have to multiply by the reciprocal. Okay? So over on the right-hand side here, I'm just giving you an example. Instead of that ugly fraction that we have here, what if the fraction was just 3/4? Then we multiply by 4/3 on both sides, right? That's the reciprocal. And then we could solve for what m is. So the only reason that this is harder is because you might not see or notice that it's a giant fraction. Um, and of course, if we can see it as a fraction, just do the reciprocal or check out the reciprocal in the answer choices, it's got to be D, right? So D has that whole thing where we have the reciprocal, it's being multiplied by the T, and then because it's M minus F, we have to add F to both sides, so that plus F is right there. In number 15, this one's kind of a little bit tough. One way to kind of get around um, the exponent properties and the manipulation that you have to do is just to kind of see that you could plug in a value of x like x equals 1, right? That works out pretty well because that would basically allow you to see that a equals 1 is what would be the result of plugging in x equals 1. And then if you use that in here, right, the 7 to the x is equals ab, then you'll find out that, hey, the b is just equal to 7/8, and that's a. Okay. Now, if you do want to look at the exponent rules, you could do it that way. You just need to, like, again, be comfortable with manipulating exponents and using the properties in your favor. So 7 squared times x, so to the x power, is the same as 7 to the x squared. So that's the way we're going to kind of interpret that 7 to 2x. All right. And if we do it like that, then we can substitute in 8ab for that 7 to the x. And then, as you can see in the steps over here, if we then cancel out the a squares, we'll take the square root of b squared on both sides, and then we get plus or minus 7/8. The final answer is a, again, 7/8. Number 16, we're looking for the y-intercept. So, hey, how do we find the y-intercept? Just set the x equal to 0, right? Think about it. All y-intercepts are points where the x is equal to 0. So if we do that, then we find out that the y-intercept is at 0, 2. Of course, that means c is 2, but they want c squared. One extra step. C squared equals 4. And number 17, we've been seeing basically one trig question per week. Um, on this one over here, again, it might be helpful, or if you have learned it in school, to just go over, review the values of sine and cosine in quadrant 1 for those reference angles. But even if you don't know how to do that, you can still get the answer. Okay. Um, so if you have any question about sine values, cosine values, don't be afraid to draw out the right triangle. Okay. We know that in this case here, it's sine of x equals 1/2. Well, that basically lets us know, right, because of the 2-to-1 relationship, if we look in the front page of the math section, that's the exact same relationship that we see in a 30, 60, 90 triangle. So then that allows us to see that the missing side is x root 3 or a root 3 value. All right. The other way to do it is, of course, just remembering a right triangle. You can use the Pythagorean theorem to get the missing side. But either way that you do it, you could then calculate that the value of the cosine of x is root 3 over 2. Okay. So use what you know about the Pythagorean theorem and or special right triangles to get it, or just go right to the trig table because you might have memorized it in school or for the SAT, of course. In number 18, this is again an exponent property question. I have a lot of the exponent properties way up here in the top right hand corner written out. In this case here, I just reduced the b to ninth over b cubed and turned it into b to the sixth. Then I kind of just showed you that b to the sixth, you could write it out like that. And then you could think of it like this. And then, of course, if you have a root multiplied by itself, it's just equal to the value out in front, the 6 there. We can combine square roots when they're a product like that. And then that gives us something that is square rootable. It simplifies to the square root of 64. And that, of course, gives us 48 in the end. And then finally, number 19. Okay, this one's kind of tough. There's one method which is reliant on a shortcut. You can look up combined averages and mixtures in the IS workbook in Unit 2. That has this kind of weird method of finding the differences between the two extremes and the mixture in between. And then that flipped around becomes the ratio of values. And that tells us, oh, it's 1 unit of 5% solution for every 2 of the 14% solution, and we can use that to find it's 12 ounces of 5% and 24 ounces of 14%. I think that shortcut is kind of obscure and hard to remember. It's not used very often. So I think many of you would probably be kind of more enthusiastic about the algebra method, right? In terms of, oh, this is something that you can kind of just like recognize and do, even though it takes more work. So I like to organize my thoughts. I used a little picture here. So what's unknown? We don't know X, the number of ounces in the 14% solution. That's the one variable that we don't know. Otherwise, we're just adding the contents together, and we've got the respective percents there. So one equation is going to be pretty simple. It's just going to be, you know, oh, sorry. The equation that we get is going to be just a combination of the percents and the quantities, right? So 5% of 12, 14% of X, added together is going to give us 11% of 12 plus X. In essence, we're trying to find out how much acid there is in this solution, in the system. So if we multiply it out and we can solve for X, we can then use the conversion. I did a proportion to convert from gallons to, oh, sorry, from ounces to gallons. Okay, so there's the work right there. If you have any questions this week, I'm sorry that I wasn't able to kind of be there live. Obviously, if you're looking at this video, it's probably because there was some sort of internet issue. Don't be afraid to reach out to me via email. My email is bingshen, my name, BINGSHEN, @gmail.com if you have any questions pertaining to this week's workshop test. So hopefully I'll be there live next week. Hope you have a good week and best of luck.